Question 6. In the binomial expansion of x minus y to the 10, how many terms will be positive? Justify your answer. All right, this is a 2-mark question, another one on the binomial in the first part. So how do we do it? Well, again, I guess we can recall the single term of a binomial is n choose k, a to the n minus k, b to the k. And this is for term k plus 1. So right from our formula sheet. So, if we're looking for term 0, how do we find that? And we actually have to kind of get an idea about all the terms, because we're asked how many terms will be positive, or at least establish some type of pattern. So again, n is 10, but it's important to note that there are 11 terms in this expansion. Okay, so in attempt to establish some type of pattern, because we don't really want to have to find all 11 terms, we just want to establish a pattern, save some time. But I will, find the first term. So the first term, term 1, k would be 0. So that's 10 choose 0, and a x to the power of 10, right? 10 minus 0, and negative y to the power of 0. All right, let's try to find term 2. Well, not much of a difference. It's 10 choose 1, x to the 9, and negative y to the 1. And let me just find the third term. The third term is 10 choose 2, x to the, 10 minus 2 is 8, negative y squared. So I'm getting bored with this quite quick, but let's see if we could establish some type of pattern. So really we're just concerned what's positive and what's negative. So 10 choose 0 isn't doing anything for us. We know it's a number, and it's 1. There's only one way of choosing nothing from 10. X to the 10, well, that's a positive right there. Now because it's a positive coefficient. So negative y to the 0 is a little bit tricky, but it's just 1. And lots of people will look at this expansion and just say, the first term is x to the 10. The last term is minus y all to the 10. So you can know that. So the idea here is it's positive. Okay? If we look at the next term, well, this doesn't matter. That's just positive. But what matters is this term right here. Negative y to the 1 is going to give us a negative coefficient. And then in a similar fashion, we could look at term 3. 10 choose 2 is some positive number. X to the 8 is not changing our coefficient. Negative y squared, well, a negative times a negative is a positive. So from my experience in class, and hopefully you realize this, that sometimes binomials alternate. And I think this is definitely one of those binomials that is alternating. So let's just find term 4 just to make sure. Okay, so term 4 would be 10 choose 3, which again isn't determining anything really in relation to the sign. So all that really matters is this part right here, negative y to the 3, right? What's going to matter in term 5? What's going to matter in term 5 is the negative y to the 4 part. So it's going to go negative, positive, because it's an even power. In term 6, what's going to matter? What's going to matter is this part. That will be a negative y to 5. So I think you're getting the hang of this. It's going to alternate. Positive, negative, positive, negative, positive, negative. And now let's just keep going. Term 7, term 8, term 9, term 10. And we're just convincing the marker here that we know what we're doing. So this would be positive, this would be negative, this would be positive, this would be negative, and of course the last one's positive. What's the last one? We know the last one is negative y to the 10. Okay, so let's go ahead and let's circle all the positives. 1, 2, 3, 4, 5, 6. Okay, so 6 terms are positive. And that's without finding what they actually are. Okay, but if we wanted to find coefficients, we could also use Pascal's triangle. But that's not important for this problem. We're just establishing a pattern and answering the question.